Hello, geometry. So this year I'm really modifying chapter 2 because of COVID. All right, I know that proofs can be a struggle even when we're in person, so we're still going to be justifying a lot, but just so you know, this is kind of modified chapter. So today we're going to be talking about what can we assume in a diagram and what do we have to have labeled for someone else to know. Because when we have these diagrams, we're communicating with someone else. All right, we're communicating with them. I'm sure you guys have heard the phrase, a picture's worth 1,000 words. Same idea with geometry. In fact, it's even more important. This geometry is what architecture is based off of and lots of those things, right? So it's really important that we know what we can look at and we can say, hey, that's true, and what we have to have labeled. So, for example, when we are identifying angle measures, we have to have them labeled. So if it's a right angle, for example, like right here, we've got our angle. We know it's 90 degrees. Sometimes you'll see the little 63 or some angled number. We have to have those labeled to know. I can't just look at an angle and say, oh, I think angle C is 90 degrees because it looks like it. Well, I might look 18, but that's certainly not the case. So another thing we need to have labeled is segment length. If it's 5 inches, if it's 3x plus 12, I can't just say, oh, well, BC is 10x. I don't know that. It needs to be labeled. Same thing if lines are perpendicular, which is indicated with that right angles, right? Perpendicular lines meet at a right angle. Or parallel lines, those are usually written like this. So they have kind of arrows in the middle of them. We'll see them a ton in chapter 3. So please familiarize yourself with how we show lines being parallel. And then congruent. Anything that is congruent has to be marked. And we know that congruent segments are marked with tick marks, right? So those two segments would be congruent. And we know that angles are marked with this whooshy. It's a different kind of a tick mark, I suppose. Sometimes we'll see double whooshies like that. And the number of tick marks corresponds to each other. So something that is just one tick mark is not congruent to those. It might look like it is, but it's not. And these markings supersede how they look. Okay, so even if I give you something like, let me do another color, something like this, and they both have one tick mark, it doesn't matter that they look different. They are the same. I am telling you with these tick marks that they're congruent. You could look at me and go, man, you're a horrible artist. I won't disagree with you. But because I am telling you with the tick marks that they are congruent, you know they're congruent. You can count on it. So some things that we cannot assume that are in these are, or some things that we can assume just by looking at it would be intersections. All right, intersecting lines, intersecting rays, intersecting anything that intersects, we can assume. All right, we can. We can assume things that are coplanar. All right, or collinear. So A, C, F, and E, or F and H, are all collinear points. They're collinear. We can assume things that are adjacent angles. We can look at it and see that they are adjacent. So we can assume adjacent angles. We can assume opposite rays. We can assume points that are between other points. So for example, F is between C and H. Now I don't know that it's the midpoint, but I do know it's between them. All right, I do know it's between them. So let's take a look at this diagram, and we're going to go through some of our statements over here and see if it's true, and then state our reasoning, okay? Make sure you can reason through why. Why can we say that? So shown are collinear. Is that true? No. A, C, F, H are collinear, and B, C, D are collinear, but they're not all collinear to each other. So no, they are not collinear. They are not collinear. They are on, oh, this is same plane. Oh, oops. They are coplanar. Coplanar. See how important reading is? So on same plane. only one drawn. Right? There's only one plane drawn. We don't have our little, parallelogram thing. Points D, G, and I are collinear. Collinear. Okay, so D, G, and I, they're all on the same line. Now it looks like I could take my pen, right, and draw a line through them. But are they all on the same line as drawn? No. There is no line, so we cannot say they're collinear. There is no single line. Let's take a look at points A, C, and H. A, C, and H are collinear. Is that true? Yes, they're on same line. They're on the same line. All right, EG, line EG is perpendicular to line AH. Hey, there's a right angle there. There's a right angle. So can we assume that they're perpendicular? Yes. They're perpendicular because there is a right angle, right? There's a right angle. All right, we want to know if angle BCA is congruent to angle ACD. Do we know? Oh, our linear pair, our linear pair. So BCA and ACD are a linear pair. So we need to figure out if BCD is a straight angle, a line. Is BCD a line? Yes. So it's because BD is a line. So that is true. All right, we have AF. Line AF is perpendicular to line BD. They are perpendicular. Is that true? No. It is not marked. It is not marked. I don't care if it looks like it. I might look like I'm 18. It's not true. It's not true. Sorry, I lost my train of thought. Oh, so the next one on here, we have AF is perpendicular. Oh, AF and BD are coplanar. AF and BD are coplanar. Is that true? Well, there's only one plane, so yes. There's only one plane, so it is true. They're both in the plane like stuff embedded in paper. All right, AF and BD intersect. Do they intersect? Yes, they intersect at point C, right? At point C is where they intersect. All right, we have angle ACD and angle BCF are vertical angles. ACD, so this guy and this guy, they're vertical angles. Is that true? Yes. It is true, and it's true because of the definition of vertical angles. Right? Vertical angles, we know, share a vertex, but no similar sides. So yes, that is true. We want to know if EG and BD are parallel. Well, they look like it, right? Is it marked though? Do we have our little arrows on there? No, it is not marked. So we cannot assume it to be true. All right, we've got EG and BD do not intersect. EG and BD do not intersect. Do we know that they don't intersect? Just because it is not known doesn't mean we know it. So it's not shown, but they could keep going way over here and intersect, right? The only kind of lines that do not intersect ever are parallel. So at some point in time, they will intersect because they're not marked parallel. So not shown, but they do intersect. All right, the next one here says EG and BD are perpendicular. EG and BD are perpendicular. Well, they don't even show the intersection. So again, this one is not shown. And there's no right angle. We know perpendicular lines have right angles. I'm going to slide this a little bit so you can see some of the rest of this. Maybe I can do it like that. There we go. Not perfect, sorry. Point D is off the page a little bit. So we've got AC and FH are the same line. AC and FH are the same line. Yes, they are the same line. I can name that line either way. So they are collinear. All right, F is the midpoint of segment AH. F is the midpoint. We don't have any tick marks on here, so we cannot assume that. It is not marked. All right, point C is the midpoint of segment BD. C is the midpoint. Well, is it marked? No. So we cannot assume it. It is not marked. Line BD intersects with line EG. Line BD intersects with line BG. We don't know. It's not shown. Now, the only kind of lines that don't intersect are parallel, and they're not marked as parallel, so they might intersect. They should intersect, but we don't know where. It's not shown. So we cannot say for certainty that they intersect. The next one is angle BCA and angle BCF are congruent. Angle BCA and angle BCF are congruent. Do we know that they are congruent? No, we do not. This is not marked. So hopefully what you're taking away from this is that there's a lot of things that we can get from a diagram, but there's a lot of things that we can't get from a diagram, okay? There's a lot of things that we just don't know that aren't shown, all right? So if it's not shown, if it's not marked, then we can't do anything about it. Now, one of the things I want you to be aware of is some of these postulates here. We've already talked a lot about them, especially in chapter 1. We know that any 2 points form a line. We know that a line contains at least 2 points. All of this you guys know already. The line intersection postulate says if 2 lines intersect, then their intersection is exactly 1 point. Again, going back to chapter 1. The 3-point postulate, so we can use any 3 non-collinear points, and it will form a plane, exactly 1 plane. Or we have a plane contains at least 3 non-collinear points. The plane line postulate says if 2 points lie in a plane, then the line connecting them lies in the plane. And the plane intersection postulate says if 2 planes intersect, then their intersection is a line. The line's perpendicular to a plane. So this is actually a definition. A line is perpendicular to a plane if and only if, it's a very powerful statement, if and only if the line intersects the plane in a point and is perpendicular to every line in the plane. All right, perpendicular to every line in the plane. So if I sketch out a little picture of this, we could have that be a line, and that be a line, and that be a line. And if we have, I'm going to do it in black so it's easier to see, a line like this, and it's got a little right angle there, then we can say it's perpendicular. If it's not marked, though, then we can't assume it. The next thing I want to look at is just the identity of postulates from the diagram. All right. So take a second. I want you to try this one, the plane line postulate. So planes intersecting with line or being in lines. And then the plane intersection postulate. So where do planes P and Q intersect? Try those out. All right, the last thing, we want to sketch the intersection of plane R with line S at point G. So pause the video, try it out. So here's plane R, and here is line S, and this is point G. All right, plane R, line S, point G. We want to sketch the intersection of line AB with segment BD. So this is a line and this is a segment. So here is A and B, and then I want segment BD. Now I already have a point B on here, so I need to start there, and here is my point D. So my segment BD, my line AB, and they intersect at B. Hopefully that makes a lot of sense. If you're struggling with this, please let me know. I am happy to help. There are some more examples on the back, and I have included all of this in the notes as well. So you are welcome to email me if you have any questions.